So for 8.6, we're going to be adding a third variable to our systems. So here I like to actually number them. They won't number them, but I'm going to call our first, second, and third equation. And we're really only going to add one step. Okay, so we're going to do this, and I'm going to start with one of the harder kind of versions of this. But these are kind of going to be our steps for the hardest versions, and there's going to be some that are actually easier where part of the first step is already done. But our first step is going to be, we have three equations, and I have to choose two pair of equations to eliminate the same variable. Okay, and there's not really a bad choice here. If I look, the x's, obviously these wouldn't cancel, but this is a 1, could cancel. That's not a bad choice. The y's here could cancel, the z's here could cancel. So there's really not a bad choice. What I tend to have students do is they go, you know what, I'm terrified of the z since I haven't seen it before, so let's go ahead and get rid of the z's. Okay, well, if you wanted to do that, these two would be a very good equation to do that with. 1 and 3. Why? Because the z's are all ready to cancel out. See, if I bring them down, x plus y plus z equals 2, negative x plus 2y minus z equals 1. Well, actually, we're kind of fortunate because the z's cancel out, but so does the x's. So we're just left with 3y equals 3. You can divide, and we have now that y equals 1. So that was actually a good choice. But I have to choose a second pair. So we've already chosen 1 and 3, so I can't choose 3 and 1. I have to use equation 2. The question is, what do I want to use it with? Well, if I'm getting rid of the same variable, so I'm still getting rid of the z's, what I would do is I would use equation 2 and 3 since they're already opposites, and I would just take equation 3 and multiply that all by 2. So what would that become? Negative 2x, make sure I'm not changing in the signs, plus 4y minus 2z equal to 1, and then this one I would just bring down as it is. So x minus y plus 2z is equal to 2. What this does is it lines up the z's so they cancel out. So now I'm left with negative x plus 3y equals 3. I'm going to box that in. That is one of my new equations. Okay, so that's step 1. That we've actually gone back and we're making this back into a 8.5 question. Just by eliminating one of the variables, now I'm going to be left with two variables, and so I literally can switch this back to a question much like previous sections. What do I do now? Well, I use these two new equations. I use this work that I did here, equation 4 and equation 5, and I'm going to use them to solve for another variable. Well, the good news is we already know what y is. So this is all step 1. That's the hardest part. The second part's easy. I take basically these two, and I can, well, I'm actually really fortunate, I can plug in this y, so I can say negative x plus 3 times y, 1, equals 3. Negative x plus 3 equals 3. Keep solving. Negative x is equal to 0. Dividing by the negative, x is equal to 0. All done? No. Because I have solved for x and y after the first two steps. You've done, you've really done like 90% of the work, but you're not going to get full credit at this point. What do we still have to do? Well, I still need to find z. Well, how do I do that? Well, that's step 3. I'm going to go back to any of the original equations, and I'm going to substitute these numbers. Sorry about that. Substitute these numbers, and I'm going to solve. So I'm going to go back to the equations, and I'm going to choose one where z is easy to get to. How about equation 1? So x plus y plus z is 2. So step 3, x plus y plus z is 2. X is 0, plus y is 1, plus z is 2. 1 plus z is 2. Z is equal to 1. All done? No, I need that last step, which is what? Write your answer as a point. See, before we had an x comma y, this is 3 variables, so it's x, y, z. So it is 0, comma 1, comma 1. That would be our last step. So like I said, the only tricky part is that first step. I know that seems very overwhelming at first, but these are kind of the generic steps that we're going to use. Obviously, some things very fortunate happen, like getting that y by itself. Awesome. But the process is not really that different. Here's another example. It looks a little terrifying. I'm going to choose a variable to get rid of but I don't like this fraction. So I'm just going to take that equation 2, and I'm going to go ahead and multiply that by 2 right off the bat. So that becomes a negative 2x plus 3 over 2 times 2 is just 3, minus 4z is equal to negative 8. Well, now I have a negative 4z, and up here I got a positive 4z, so I'm going, well, that's not bad. I could actually eliminate the z's again. And since a lot of people are intimidated by that, we'll do it. Okay? So looking at this, what do? Well, 2x minus 2x, 0, 0, 0 equals 0. What does that mean? Well, that's actually a good thing, so don't get mad about that. That we've seen before. That means that if I was to graph these systems of equations, they would have many solutions. Okay? So basically it will be the solutions of x, comma y, comma z, such that it fits in any of these equations. I'm okay with that. You can just put many or infinite solutions, and I will be fine with that. Okay? Let's keep going. This one looks a little more complicated. I don't know why I left those parentheses in there. Sorry about that. Alright, so I'm going to eliminate the same variable. Which variable this time? I like the 3 with the 6. That wouldn't be bad, but that 5 kind of stinks. I like it the 5 and the 10, but that 8 kind of stinks. I think I'm going to do the z's again. So I have a positive 2 and I have a negative 1. I'm going to choose equation 1 and equation 2 to try to get rid of those z's. Okay? And we'll save 3 in a little bit. So out of these two, if I took the second one and I multiplied it by 2, I would now have, what, 10x, 16y, minus 2z equal to 8. And this one I could just bring down, 3x minus 5y plus 2z equal to 1. So now those are lined up and the z's cancel like we wanted. So now I got 13x plus 11y equal to 9. Box that in. That's one of our new equations. Call that equation 4. Now I have to get rid of z again. Well, I just used 1 and 2, so I have to use equation 3 with one of them. Well, I'm looking at equation 3, and I'm liking how this is a positive 2 and a negative 4, so I'm going to line up 1 and 3. I just need to basically take the top one times 2, and that makes that a 6x minus 10y plus 4z equal to 2. The z's cancel out like we wanted, but so do the y's, so do the x's. So this is weird. I'm left with 0 equals 7. Is that a problem? Well, no. What does that mean? Right? That means that these two, no matter what we do, are never going to equal. So if I was to graph these 3 lines, they would not have a point in common. So this actually has no solution. Or I think the book calls this a contradiction. Basically, there is no value of x, y, and z that can make all 3 of these equations true, because these two are basically like parallel. They never cross each other. Again, choose 2 pair. I'm just going to keep following those steps. Well, the good news is, and once again, if you're terrified of z's, these are really nice to cancel out. But this one already doesn't have a z. I'm going to box that in as one of my new equations. Why? The z's are already missing. So that part of that first step is already done. It says choose 2 pair to eliminate the same variable. That is already missing the variable z. So that's already one where the variable's gone. if I could take these two and add them, I would get 9x plus 8y, the z's cancel, equal 12. Now I can use these two to eliminate another variable. See, this is all step one. It doesn't have to be a big complicated process, okay? Now I look at these two and I go, okay, now I'm on step two. This now looks like an 8.5 question. I'm going to use this top equation and this new equation, like our equation 4 basically, to try to eliminate another variable. Well, the x, 6, and 9 don't really cancel out. 12 and 8 don't really cancel out. But at least the 12 and the 8 are opposite, right? I need these to be opposite, but they must also be the same number. So I'm thinking I can make a 12 and an 8 both into a 24. How would we do that? This equation times 3 would make that 27x, 24y, and I believe 36. This equation times 2 would give me 12x minus 24 and negative 10. The y's will cancel out. So what we've done is we now have a single variable, 39x, is equal to, what is that, 26? Uh-oh. Dividing by the 39, I have a fraction. That does simplify. They are both divisible by 13 to give me, I think, 2 over 3. But does that mean I messed up somewhere? I must have, right? I ended up with a fraction. We'll double check. Let's see. This equation times 2. 6 times 2 is 12. 24, negative 10. That's good. This times 3. 27. 24 times 3 is 36. These two combined, though the 8y and 9x don't combine, the z's cancel, and left 12. I'm not seeing any mistakes here. So we can have fractions show up as an answer. Okay? So don't freak out. That's just one of our answers. What do I do with that answer? Well, step 3. I'm going to plug that answer not back into the original equations. I want to plug it into where I only have 2 variables. So either our top equation or our fourth equation that we made, but we're going to plug the value, the answer we just got, our answer, into one of the new equations. Why the new ones? Because they only have 2 variables. So I'm going to go ahead and take equation 4, and I'm going to do 9 times x plus 8y equals 12. Well, even with that being a fraction, that's not too bad. 9 times 2/3 is 6. So 6 plus 8y equals 12. Subtracting the 6, 8y equals 6. Dividing by 8, we get y is equal to 6/8. Let's reduce that. How about 3/4? Oh, really? Again? Okay, well that's all right. That's part of our answer, right? So what do we do now with these two? Well, I'm going to go back and find one of the equations that had a z. So I'm basically going to plug these numbers into one of the original equations. Why? Because that's where I have a z. So basically equation 2 or 3, I'm going to plug this into. Which of those has a z that's easier to solve for? Probably the +1, right? So I'm going to bring down that 8y plus z equals 0. 8y, 8 times y, 3/4, plus z equals 0, I believe, right? 8y plus z equals 0. Okay. 8 times 3/4 is 6, plus z equals 0. Subtracting, z is equal to -6. Just to recap real quick, make sure I'm not doing anything wrong. This was all step 1. Step 2 was eliminating another variable and solving. Once we had that solution, step 3 was plugging that solution in and solving for the second variable. Step 4, go back to an original one where I can find the z. And last but not least, make sure you write your answer as a what? our answer is a point with an x value of 2/3, comma 3/4, comma -6. Write your answer as a point, x, comma y, comma z. Okay? We're also going to have some word questions, just like we did in 8.5. We're going to have word questions in 8.6. Okay? We need to make sure that we're comfortable with a cost formula. We need to be comfortable with the total. So here's an example. A purchase made at Acres Bakery. Hey, about that, for $87.89. There was wheat bread for $2.95 per loaf, sunflower bread $2.99 a loaf, and French bread $5.79 purchased. The amount of wheat bread purchased was 3 times the amount of sunflower, and the amount of French bread was 5 less than the amount of wheat. How much of each type of bread was purchased? Okay, this $87.89, that is a total cost. That is the $87.89. How did we get that? Well, it was each amount, x being the amount of wheat, y being the amount of sunflower, z being the amount of French bread. By the way, it's kind of hard sometimes to keep track of x, y, z. So I'm going to go ahead and say I don't mind if we use w, s, and f. The cost of the wheat, how much did we spend, was $2.95 times however much of wheat bread we bought, w, plus the cost of the sunflower, I put sunflower bread, was $2.99 times s, however many loaves of that we bought, plus the cost of the French bread, $5.79 times f, however much French bread. So that is one of the types of equations they'll give us. Okay. Another one they could give us is if they gave us a total and they said like 37 loaves were purchased total, then that would be where we'd use the total bread. This question didn't give us that. So we're not going to have a total on this. If they said there was this many loaves purchased total, that's what we would do. But currently I only have one equation, and that does not work with a 3 variable. I need 3 equations. Okay, so that's where these sentences come in here. The amount of wheat bread was 3 times the sunflower. So the amount of wheat bread, w, was equal to 3 times the sunflower, 3s. We have a second equation. It says the amount of French bread was 5 less than the wheat bread. French bread, f, was 5 less than the wheat minus 5. Box that in. These are our 3 equations that we're going to use. Okay? Now I definitely don't like that first one. It's the most complicated of them, especially because the numbers are so big. So when I bring this down, I'm going to make all those whole numbers by multiplying that by 100. So I don't like that line right there, so I'm going to move it. So everything times 100. So that's going to make that 87.89, 295, 299, and 579. So at least I'm dealing with whole numbers, right? Our second equation is w equals 3s, f equals w minus 5. So how do we want to handle this? I would just probably substitute the crud out of this thing. See, everywhere I see a w, I can put a 3s. So just doing that, and everywhere I see an f, I can put a w minus 5. So I'm going to take this top equation, which is, I know, kind of terrifying, but say 87.89, no decimal there, it's just a dot I left, is equal to 295 times w. What is w worth? 3s. Plus 299s plus 579 times, what is f? Need more space. 1 second. There we go. Need a little more space there, so I'm sure you can all just shrink yours there too. What was f? How about w minus 5? Okay. we are almost down to one variable. We went from W, S, and F, and now we have S, S, and there's still a W in there. But I can take that W again, and I can replace it with a what? Well, 3S. So 87, 89. I'm going to start cleaning this up as we go. 295 times 3 should be... I think. Let me double check that. 295 times 3. Let me just get to a calculator here. 295 times 3. 885. S plus 299S plus 579 times, how about 3S minus 5? I can start combining like terms, just still simplifying. 87, 89 is equal to, those two are going to combine to make 1,184, I believe. 885 plus 299. 1184. Hey, we're feeling good about this. This is going to distribute. 579 times 3. What would that be? 17 something. So 579 times 3 and 579 times 5. 579 times 3. And 579 times 5. So 1737. So that would be 1737S minus 2895. Still combining like terms. 87, 89 is equal to, what is that going to be? 11, carry the 1, 12, 9, 10, 3021. 1184, 1737. 2921. Ooh, did I mess up? 1184, 17. I sure did. See? It happens. So that should be, I think, 2921. Double check that. Alright. We are going to add 2895. And we're going to start saying a little prayer, hoping this is divisible by 2921. So let's see, 4, 7, 15, 16, 10, 11. So 87, 89, 87, 89, 28, 95, 87, 89. Plus, what was it, 2895, or is that something else? Yep, 2895. $11,684. Oh man, someday I'll learn how to do math. Divide that by 2921. And we've got S is equal to 4. Thank goodness. That is all the hard work. Not that we're done, but that's all the hard work, because what? Now that I have this S, I can plug it back into the original equations. What is W worth? Well, 3 times S. What is W worth? 12. What is F worth? W minus 5. 12 minus 5. So I understand that this is overwhelming at the beginning. We have a lot that goes on, but once you get past that first kind of complicated step, man, this thing cleans up so easily. So don't get overwhelmed. Persevere through this, and you should be doing fine. Just for fun and giggles, I can actually verify. Let's see. 12, 7, and 4. 12, 7, and 4. So let me think. It was 12 wheat. So 12, 7, and 4. 12, 7 is F. All right. So 12, 7, and 4. I can actually verify that 295 times 12 plus 299 times 4 plus 579 times 7 should be 8789. So let's look. 295 times W plus 299 times S, S was 4, plus 579 times 7, and that should be 8789, 8789. Those are the numbers that give us that cost. Okay? So like I said, I know this is a bit overwhelming, but that would be everything we need to make sure you know how to do. Just persevere through these. It adds one step. This is really the only one big new thing in Chapter 8. So tough it out. And let's get ready to start Chapter 9.